In this video, we will talk about how to solve system of equations by substitution. To be more specific, we will talk about how to solve a system of linear equations in two variables by substitution. So we're going to start with the question, what is a system of equations? A system of equations is a set of equations that work together. And if you have linear equations only in your system, then it's a system of linear equations. And if the two linear equations have only two variables, then it's a system of linear equations with in two variables. So the type of questions that we will be looking at in this video are a system of linear equations in two variables. Here's an example of what a system of linear equations in two variables looks like. So I have two equations in both the examples. Both of them are linear equations and both have only two variables. Now, what does it mean to solve a system of equations? It means to find a point or points that satisfy both equations. We just said that the solution to a system of equations is a point that satisfies both equations. So let's see, in this example, we're told that 3.5 is the solution to this system. We will substitute in the first equation, x is equal to 1, and we're going to solve for y, and that gives me y is equal to 3.5. Similarly, in the second equation, I am going to substitute x is equal to 1, and I'm going to solve for y, and again I get 3.5. So what that means is that the point 1, 3.5 satisfies both equations, and that is what it means to say that a point is a solution to a system of equations. Now, how do you solve a system of equations? There are three popular methods: solving by graphing, solving by substitution, and solving by elimination. In this video, we'll solve a few examples by substitution. Substitution means to replace something, a variable or an expression, with an equivalent variable or expression. So in other words, you take something out and you replace it with something which is of equal value. Here's example number 1. P is equal to 1 over 4x plus 7 over 4, and P is equal to 0.25x plus 1.75. So what I'm going to do is I'm going to take 1 over 4x plus 7 over 4, and I'm going to replace the P in the second equation with that. So it's important to remember that the substitution must be done correctly. So I'm going to start writing the second equation, but instead of P, I will write what the value of P was from the first equation. So 1 over 4x plus 7 over 4 is equal to 0.25x plus 1.75. And this gives me 0.25x plus 1.75 is equal to 0.25x plus 1.75. And if I solve this, I will get 0 is equal to 0, because I can cross out 0.25x on both sides, and I can also subtract 1.75 from both sides, leaving me with 0 equals 0. Now this is a very special case. Whenever you get a number equal to itself, that is a statement which is always true. What that means is that there is an infinite number of solutions. There is an infinite number of solutions. Let me write that down. And the second thing that we do know is that these are coincident lines, or these equations represent coincident lines. So these are actually lines which lie on top of one another. Here we go. So whenever you get either 0 is equal to 0, or 1 is equal to 1, or 25 equal to 25, or negative 5 over 3 over negative 5 over 3, that solution represents a set of coincident lines, and that's there will be an infinite number of solutions to that system. So here's our example number 2. First equation is y is equal to 2 over 3x plus 1. Second equation is 2x minus 3y. So what I'm going to do is I'm going to start writing my second equation, and instead of writing y, I'm going to actually substitute what y is equal to in that equation. So y is equal to 2 over 3x plus 1. So in the second equation, I'm going to replace y by 2 over 3x plus 1. And now I'm going to simplify this, and I get 2x minus 6x over 3 plus 1 is equal to 6, which gives me 2x minus 2x plus 1 is equal to 6, which gives me 1 is equal to 6. Now this is impossible. We never can say that 1 is equal to 6. And in this case, when you find something like this, what that means is that there is no solution to this set of equations. This is an inconsistent system. So a system that has no solution is called an inconsistent system. And graphically, what does this represent? This system represents two parallel lines. So the two lines which are given, or the two equations which are given, they represent lines which are parallel to each other. So here's another example, and what I can do is I can take this first equation, and from here I can isolate the g. So I have g plus 5h is equal to 37. If I subtract 5h from both sides, then that gives me g is equal to 37 minus 5h. And then I can take this value of g and I can substitute it right in here, so that this second equation becomes 3 times 37 minus 5h plus 4h equals 34. Use the distributive property. 3 times 37 is 111, minus, and 3 times 5 is 15. So 111 minus 15h plus 4h equals 34. And then I can combine the like terms. So 111 minus 11h, negative 15h plus 4h equals negative 11h equals 34. And then I can subtract the 111 from both sides. And that gives me negative 11h is equal to negative 77. And then divide both sides by negative 11 to give h is equal to 7. Now that I know that h is equal to 7, and I also know that g is equal to 37 minus 5h. So I can substitute this value of h in there. So 37 minus 5 times 7, and that gives me g is equal to 2. So the solution to this set of equations is the point 2, 7, assuming that I'm writing it as an ordered pair g comma h. So let's solve this example here. We've got 5x minus 8y equals negative 48 and x is equal to 2y minus 11. What I can do is I can take this value 2y minus 11, it's equal to x, so I'm going to go substitute it right in here, so that this becomes 5x. So instead of x, I'm going to write 2y minus 11, and the rest of the equation is written just as it is. So I have 5 times 2y minus 11 minus 8y equals negative 48. And then I use the distributive property. So 10y minus 55 minus 8y equals negative 48. And then I can combine the 10y and negative 8y to give me 2y minus 55 equals negative 48. And then I can add the 55 to both sides. So adding 55 to both sides give me 2y is equal to 7. Divide both sides by 2 gives me y is equal to 7 over 2. And now that I have a value for y, I can just take this value and substitute into the second equation, which says x is equal to 2y minus 11. So x is equal to 2 times, instead of y, I'll write 7 over 2 minus 11, and that equals 7 minus 11, which is equal to negative 4. So the solution to this set of equations is the point -4, 7/2. I hope you liked this video. If you did like it, please hit the thumbs up and the subscribe button. Don't forget to hit the bell icon so that you are always informed of new videos. If you would like to see a video on a certain topic, please write an email at info@sageeducational.com. If you would like to see a video solution of a problem that you are not able to solve, email that problem as well to info@sageeducational.com, and we will have a video video solution made for that particular problem. Again, I hope that you like this video.